Objective: teaching your machine to differentiate between different classes of iris flower. Concept: classification. It refers to a predictive modeling problem where a class label is predicted for a given example of input data. 3 classes of iris flower: Iris Setosa, Iris Versicolor, Iris Virginica. If you randomly select a flower belonging to one species and give it to your machine, will the machine be able to recognize the species? The answer is no. Why? Because the machine doesn't know how to do this task. It needs to learn it first. Just like you. How to make the machine learn? The difference between the 3 species lies in the different sizes of their petals and sepals. We make our machine learn this difference using a dataset containing the length and width of sepals and petals. Using the dataset, the machine learns to group together similar flowers and learns their characteristic. For example, our machine reads the length and width of petals of the flowers provided to it in the data. The machine then learns that some flowers have similar dimensions of petals while others don't. Keeping a note of this difference, the machine arrives at a decision. Our machine is now ready to take the test again. Our machine has now learned to classify different species of iris flower. Types of classification. Binomial. It is a type of classification with 2 outcomes, for example, either true or false. Multi-class. The classification with more than 2 classes, say Class A, Class B and Class C or more. In this type of classification, each sample is assigned to one and only one label or target. Multi-label. The classification with more than 2 classes, say Class A, Class B and Class C or more. In this type of classification, each sample is assigned to more than one label or target. Classification of iris flower dataset is a multi-class classification task. Now that you understand the concept, let's move on to coding. There are many algorithms that can perform a classification task. We will perform classification using decision tree.
Code. We first import all the necessary libraries for various functions such as data loading and visualization, data pre-processing, implementing decision tree, and evaluation of model. First, we load the data into a data frame. We can check the details of the data frame as shown. We need to scale the data for a better result. If we don't scale it, the feature with a higher value range starts dominating the calculations. We now split our data into train and test sets. We build a default decision tree model using the train dataset. To make a custom tree, we can use parameters listed above. When we fit the model with the train dataset, it learns to classify the data with the available information and predicts class probabilities of the input instances. The class with the highest probability is selected as the class of the instance. Now that our model has been fitted, we make predictions on the test dataset. We can visualize the decision-making process in the form of a tree. We can see that the decision tree model has learned to classify 40 instances as iris Setosa, 41 instances as iris Versicolor, and 39 instances as iris Virginica from a total of 120 train instances. Using the learnings from this decision model, the predictions were made. We will now evaluate our model. Here we test how well our model predicted the values of y-test. That is, we evaluate how close the value of y-pred are to y-test. We will use 2 metrics for this: confusion matrix and accuracy. We can see classification performance of the model from the confusion matrix shown here. In this case, no instance have been misclassified. All the predicted values have been classified accurately. A model is as good as the data it is trained upon. Since this dataset is very detailed, our model has performed really well. As the result shows, the accuracy of this model is 100%.